Okay, hey and welcome to example 13, and this is our final example for the POPs part of this course. In this tutorial we're gonna take a look at how to do this. So rain, some splashes, and some ripples. The only two parts of this that are POPs is the rain and the splashes, but I still want to go over how to do the ripple. And yeah, so I'm gonna split this up into 3 parts, I think, which is gonna make it a bit easier to understand. But let's get into it. So I'm gonna click this, pause this, and there we go. So let's start going over the rain, how to create that. So first of all, we need a source like this. The source, we're just gonna do a grid. I'm gonna make it like it's a standard grid. I'm gonna transform it up a little bit, which is gonna be like the rain cloud or whatever, where all the drops is coming from. I'm gonna scatter points in it, about 10 points. I mean, it doesn't matter really. And then I'm gonna do the global seed to like switch around for each frame, which is cool. And then I want to initialize the velocity, and I just want to do that like a little bit randomly, like for each point. So therefore, I'm gonna take the PT num. I'm gonna do random, so I get a 0.21 value. I'm gonna do a fit to that. I'm gonna put the fit to 0.5 to 1, which means that each point can have a velocity in y that is equal to 0.5 or 1 minus, that is. How we do that is by making a vector constant, piping it to multiply, and then simply multiplying that by this value. So the 0 minus 1, 0 vector will get multiplied by randomly a value between 0.5 and to 1. And I'm just going to output that to velocity. That's simple enough. Just the velocity for each point. So they can have a different velocity for each point. I'm then going to do the source, and I take that to use it as a collision object, like as my surface. So the non-transformed, I'm going to pipe it into a null here called toCollision detect, because we don't actually use the pop collision detect in this to do some things. And that's it. Then I can jump into the popnet and take a look. So our popnet is going to be very simple as well. It's just a bunch of points simulated like this that gets stuck and turns into a group and turns red down there. So for the pop source, I haven't done much. I've just switched the emission type to all points. I've not done anything in the birth tab. In the attributes, I've multiplied the inherited velocity by 10, just to speed up the particle a little bit, like that. And then I've added a pop collision detect. In this, I've done the collision from the second context geometry, which means that the second geometry that is inputted to this pop node here is this. So therefore, let's see, therefore, everything that it's gonna touch or come in contact with this collision grid, it's gonna accumulate hits. It's gonna be input to a group called hit GRP, and it's gonna get colored. And I put the response to stick, because I don't really want to do anything else with them. I don't want them to bounce, I don't want them to slide. I just want them to be there, because I'm gonna use this later to make the ripples and make the splashes. But that's it for the popnet, and nothing else fancy going on in here. So let's go to the first branch here called drops. So here I just want to focus on the drops, right? And the drops stops existing when they turn into red and when they turn into hit GRP group. And therefore I want to delete them. So we can just do like that. We can delete hit GRP, and that means we are selecting everything that is in the hit GRP group coming out of the popnet, and we are blasting it or deleting it. Then I want to trail these points, like so. And this is just for visualization purposes. When you render these, you kind of want to render them with velocity, or motion blur, and then you don't really need to do this thing. But I want to do it now to visualize this thing and just learn some things from it. But yeah, so I'm going to trail these points just to make a copy of them that is back in time, basically. And therefore, I can do the simple trick of doing an add to add lines for these. We can add the lines by doing polygon, by group, and by attribute, and then the attribute is ID. Because as we all remember, we get an ID attribute coming out of the pop net here. These points only have 2 points. These lines only have 2 points now. We're gonna resample that to make some more geometry. We're gonna put an UV attribute on these. You guys should be familiar with that by now. We also want to do some modification here. We're gonna put a ramp from the UV because we kind of want to make these look like water drops, which is like thin at the top and kind of blobby at the bottom, but still like a blob. So how we're gonna do this? We pipe the UV to ramp, and in the ramp we create this kind of shape, kind of like a water drop shape. We're gonna multiply that by a random value by the ID, just randomly, and we put that and multiply it just to get some randomness in the width and stuff, and then we bind that to a width attribute, and that's it. We're gonna use the width attribute later on here in the polywire to actually skin these lines like this. So as you can see, they might turn into these blobby shapes, and it gives kind of cool look when you like semi-distance away from them like that. And then we color them, and that's it. So these are colored red just for visualization purposes. We kind of want to define more values or maybe even refraction if we do some rendering of them later, but for now we're just gonna do this simply. And that's it for the first branch. Yeah, so that's the water drop part of this. Next up is the splash part.